Good afternoon. I hope that we can start our session. It is already on the recording mode, so we will upload the recordings. So it will not be an issue whether there are less participants or not. So they can get their queries done through the recording that we will upload on our website. Good afternoon. So we are having today is the third outreach session for the DPSU technical outreach session, and we have four DPSUs for which it was planned. And last day on the 23rd, well was not able to connect for one of the challenge. So first of all, we will have well to present their challenge. So let me brief about the structure of the session. The structure will remain the same. We'll first have the basics launch video, then we will invite the respective DPSUs to present their challenge, and then based upon the challenge, if any query exists, they can raise that query, and otherwise we can move on to the next DPSU. The session, we always have this technical outreach session commencing, and that can be reached through the IDEX website. There the schedule is gets updated daily, and so that meeting link, the recorded session links come up over here once the technical session is over.
Newly formed companies from OFB corporatization that are Munitions India Limited with two challenges, Gliders India Limited with two challenges, India Optel Limited with four challenges, Troop Comforts Limited with two challenges, Armored Vehicles Nigam Limited with three challenges, and Yantra India Limited with two challenges.
YIL is participating for the first time and has stated two problems. I hope from IDEX will bring innovative solutions to these problems. Jai.
One challenge from the Indian Army, one challenge from the Indian Navy, two challenges from the Indian Air Force, and for the first time, three challenges from the Indian Coast Guard.
We have introduced three niche ideas under the IDEX scheme. This is the vision of making it India and how to be a Jai.
Also, for the first time in IDEX, Ministry of Home Affairs has participated with 7 challenges. These challenges span across a wide range of advanced technologies, including artificial intelligence, advanced imaging and sensor systems, big data analytics, autonomous unmanned systems, secured communications, etc. Inviting startups, MSMEs, individual innovators, research and academic professionals to apply for DISC 6. Selected applicants will get grants up to rupees 1.5 crores, along with the opportunity to co-create and co-develop the defense technologies of the future with our armed forces. Besides the grant, selected winners receive product and business acceleration support from IDEX partner incubators. Access to defense facilities for QA and certification. Applications are open at idex.gov.in.
Now we can start with the DPSUs. So first I would like to invite Well to present the challenge which left. So I hope that Well is present. Nagabhushan sir, are you there?
Yeah, good afternoon, sir. I'm available.
Okay, so then I'm unsharing. You can please share your screen and can start with your.
Right, thank you. Can I know the participant who has chosen the challenge is also available on the meeting?
Sorry, didn't catch that question. Can you repeat the question, please?
Can I know if the participant who has chosen the challenge is available in the meeting room presently?
Yeah,
Not
this is
sure.
Rehan from Core IoT. We are
Yeah,
interested
okay.
in this challenge.
Yeah. Hope you can see the slide. Am I audible? So Nagbhushan here. Am I audible to you?
Yes, we can hear you, sir.
Yeah, thank you. Good afternoon, everyone. I'm Nagbhushan representing BEL for challenge number 8, that is development to achieve uniform circular polarization in designing a cavity-backed spiral antenna operating in 1 to 18 gigahertz band. Before I can move on to the problem definition, I would like to present the context so that the problem can be understood in a better sense. BEL is involved in developing EW systems for multiple platforms, including airborne. And RWR is one class of such EW system which is being developed to airborne platforms. And the basic functionality of RWR will be to provide the situational awareness to the pilot on the arena in which he is flying, in which antenna plays a critical role in intercepting the incoming incoming EM signals, based on which the processor will further analyze the parameters and present the threats to the pilot through display. So here the amplitude that or the signal that is intercepted and provided to the processor is critical, and direction of arrival is one of the major parameters which the EW support system will provide to the user as part of its functionality. The direction of arrival is dependent or computed in many ways, of which amplitude-based direction finding is one of the methods in which is adopted in our systems, in a few of our systems. So here the radiation patterns of the antenna plays a major role in providing the amplitude to the system for further processing. So that way, here the problem definition says cavity-backed spiral antenna utilized for RWR functionality exhibits degraded performance in direction finding of target due to the following reasons. What is observed presently is the antennas doesn't show uniform gain across the operating band. From 1 to 2 gigahertz, we have seen that the gain of the antenna is relatively less with low directivity. And the second problem we have seen is the dip in the gain at bore side. Typically, the antennas will have maximum gain at bore side, based on which further calculations are done for direction of arrival. But we have seen in certain cases at frequencies at 13 to 18 gigahertz, wherein we have seen a dip in the bore side. And also to cater for all types of all polarizations of EM signal, we have preferred going with circular polarized antenna. Although typically for circular polarized antenna, the axial ratio is supposed to be 0 dB. Practically, it will not be so. But we have seen that this particular parameter has been deviating over the band. So more than circular, it turns to be an elliptical polarization. So these are the major problems which we have faced in the present situation, and this needs to be addressed. And one more constraint for this antenna is, as I mentioned, it is used for airborne platforms, and for better reception, the antennas are installed on the external surface of the aircraft, on the skin of the aircraft, and has to face different environmental conditions during its flight. So in order to safeguard the antenna, radomes are being used. So when I refer antenna, it is along with the radome, and radome is supposed to withstand all the environmental conditions which the flight will experience during its operation. And the existing dimensions which we are considering is of the antenna is having around 70 mm in diameter with a height of 75 mm. So it gives a hemispherical shape to the antenna. Moving further with the details of the problem that I have stated regarding low gain and directivity. This is one of the typical radiation pattern of the antenna at 1 gigahertz. As you can see, the beam has not formed fully. The pattern is flat, and the polarizations, what you see in blue is in the horizontal plane, and what you see in red is of the vertical plane. So the radiation patterns in different planes or different polarizations, they are not identical. Moving on to the next observation, it is the dip at both sides. As I mentioned, ideally the both sides should have maximum gain or maximum reception. But as it is seen, we have dip in the main both side, which gives a wrong indication during computation of the parameters. This is the next observation wherein the polarization is not uniform. The one in blue is of horizontal plane and one in red is of vertical plane. So ideally, if the polarization is circular, the patterns are expected to overlap in all regions. But we can see there is a gap between these two patterns. When we refer to uniform polarization, we refer that the patterns should be overlapped at least from minus 90 degree to plus 90 degree. There should be a best match. If required, there can be a deviation of probably 1 dB or 2 dB. So we expect the development to take care of these issues and to ensure rest other parameters like beam width, 3 dB beam width, axial ratio, squint, and also the back lobe in all the polarizations, vertical, horizontal, slant, and in totality circular. And this development should probably be for left-hand circular polarization. So the expectation is brought out in this particular slide. If you can see the radiation patterns here, they are well matched. They are overlapping, at least in the region of minus 90 to plus 90 degree. The variation which we expect is about 1 dB in axial ratio. So ultimately, the axial ratio shall be better than 2 dB over azimuth of plus 90 to minus 90 degree over the frequency band. And it should, by default, meet all the parameters like beam width, back lobe, squint for all polarizations. That is meaning in linear and circular, left-hand circular. This will result us in achieving a better direction of arrival with accuracy of 10 degree RMS in all sectors. Hope I could detail on the problem statement, which can help. Do you have any particular doubts on this?
Yeah, this is Rehan. So may I know the which antenna solution currently you are using?
It is a cavity by spiral antenna.
No, the data sheet or any part number.
Part number, we have sources from others, but I am not exactly getting what are you looking at in the data sheet. If possible, I can share it with you.
Okay, and as you said, the polarization is the left-handed, right?
Yeah, left-hand polarization.
Okay, and the size constraint is fixed or
We are already using few antennas, so that way we have a restriction in the size. We have to match the dimensions to the existing, so that it can be replaceable.
actually the problem is that I think you are using from like 2 gigahertz to onward, right? And we go
It
to
is
1
1
gigahertz,
gigahertz
then
onwards.
the yeah. So if we go to 1 gigahertz, then the size of the antenna should be double, right?
Okay.
So that's why I am asking if we can little bit increase the size of antenna.
As I mentioned, we are already using these systems, and the new systems has to match into the form factor. Otherwise, it requires for additional modification on the platform of the aircraft.
Okay. So if I have any further question, to whom I will contact? Can you share the details?
I think the nodal officer's details will be shared to you. Otherwise, may I know to which organization you belong, or are you an individual who is participating?
Or IoT technology.
IoT technology, is it?
Yeah.
The nodal officer's details will be shared on the website from where you have got the details of these technical events. Now, we had already shared the details for the previous sessions. We will share the details after this session, whoever is involved in this.
Okay.
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 Is there any
Okay.
more queries for this challenge?
No, thank you. Not from my side. Thank you.
Okay, now we can move towards the next DPSU. So I would like to invite IOL to present their challenges. So we have 4 challenges from IOL.
Good afternoon. This is C.S. Thakur, Joint General Manager from IOL. With me, Mr. Nitesh Goyal, Deputy General Manager, and Mr. Raghav Gupta. So, we shall be discussing our 4 challenges which we have given in this 6. Sorry, just begin. And before we go to before you want to discuss the challenges, first I would like to discuss what we do at IOL, so that the challenges the startups can correlate actually what are the products for which these challenges belong to. So at IOL we have got 3 units. One unit is basically for manufacturing fire control system and optoelectronic sites of armored fighting vehicles. Second unit is manufacturing the sites for artillery and infantry. And third unit is basically manufacturing the cables for field telephone and other equipments. Basically, this is for the cables. It is called Ordnance Factory, Ordnance Cable Factory, Chandigarh. So these core products are cables only. So these 3 units belong to IOL, And this presently we have given these 4 challenges in this SIS. These 4 challenges, 3 challenges belong to T90 tank and gyro stabilizer of gunner's main sight bungee 46, and 1 challenge belong to gyro, which is gyro motor. This belong to T72 tank gunner's main sight. The first item here, which we name as gyro chassis, this is the first challenge. This gyro chassis is actually meant for giving the line of sight stabilization in gunner's main sight of tank T90. Now, gunner's main sight is stabilized in 2 axes, horizontal and vertical. And this is the core technology which at the moment actually we are manufacturing based on TOT from Russia. And this item at present it is imported from Russia. This gyro chassis is part of gyro stabilizer assembly. Gyro stabilizer has got interface with optical channel up to mirror head mirror, and head mirror is assembly which is actually projecting out of tank. So whatever light is collected by head mirror, that light seen has to be stabilized by this gyro stabilizer with the help of gyro chassis. This gyro chassis, as I said, it is stabilizing line of sight in 2 axes. One is in horizontal and one is in vertical. And both the axes have got one common gyro motor, which is mechanical rate gyro concept. That gyro motor rotates at RPM of 28,000, and at this RPM, then after approximately 3 minutes, the gyro stabilizer activates, and then the gyro stabilizer is supposed to stabilize the line of sight after this activation time of 3 minutes. Working temperature which this gyro stabilizer is supposed to work is -30° to +55°. Weight of this whole assembly is maximum weight is 7.5 kg, and this weight has to be very, very accurate, because if we change the weight of this assembly, then other parameters have to be balanced. So we cannot compromise, we cannot have much tolerance in this weight. 7.5 kg is almost fixed weight. Dimensions of this product are mentioned here: 150, 100 into 200, all in mm. And the gyro chassis receives power of 36 volt 400 hertz from the tank supplies. And parameter for stabilization of line of sight is 1 minute 20 seconds at a rocking platform of 2.5 degree at 120 hertz. So when the tank as a platform, it is moving on an undulating ground, and the maximum disturbance of the platform is plus minus 2.5 degree at 120 hertz. At that disturbance, the gyro stabilizer is supposed to stabilize line of sight at an accuracy of 1 minute 20 seconds. So that was about first challenge. Now our second challenge is again part of gyro stabilizer of sight bungee 46. This is another assembly which is called torque generator 800. Now, as I said, gunner sight is stabilized in 2 axes. One is vertical and second is horizontal. So when gunner is trying to move his line of sight, like horizontally or vertically, so in the both axes, we have got 2 torque motors, so that the line of sight of gunner's main sight, he can maneuver for full field of view. So for moving the gunner's line of sight in horizontal direction, this torque generator assembly, torque generator 800 is used. So this is basically this is having one magnetic core, and over that there is an electrical winding, and this construction I'm explaining as per Russian design. So in Russian design TOT, this has got a magnetic core on which there is a binding, 3-phase binding, And again, input supply for this particular assembly is 36 volt 400 hertz, which is standard three-phase supply in T90 tank. And this voltage, this torque generator, as the name suggests, is supposed to generate a torque of approximately 700 gram centimeter to move the mechanical assemblies of gunner site to maneuver the site in horizontal direction. And again, the operating voltage, these are standard from, operating temperature, this is standard from minus 30 degree to plus 55 degree. The third challenge, which is very much similar to the previous one, this is torque generator 1000. This torque generator 1000 motor, this is moving the gunner's line of sight vertically. When gunner wants to see the field of view and he wants to move the line of sight vertically, the purpose and work is same. This generates the torque of 1000 gram centimeter, and the input voltage is same 36 volt 400 hertz, and the control voltage which comes from the other sub assembly of gunner side is 0 to 30 volt. So when this torque generator receives a volt of 0 means it's not absolute zero, it's like 40 millivolt. So when it receives a voltage up to 40 millivolt, it is not supposed to move the gunner's line of sight vertically. When it receives a voltage in excess of 40 millivolt, then only it is supposed to move the gunner's sight in vertical direction. And when it receives a voltage of 30 volt at maximum volt control volt, at that point of time it should generate a torque of 1000 gram centimeter, so that the gunner sight is moved vertically in the up to the maximum with the maximum speed. Now our third challenge is gyro motor of tank T72. This is only three-phase motor of gyro stabilizer, and this is for gunner's main sight of tank T72. Here the parameters are little different. The RPM of this motor is 27,900. Again, within a time lapse of 3 minutes, it should attain this RPM so that the gyro can be stabilized. Operating temperature is same minus 32 plus 55 degree, and weight here is 900 grams maximum. So, and not maximum, actually this is accurate weight. We have to have this weight of 900 gram, because if we change the weight, then other parameters of gyro need to be balanced. So we cannot be we cannot have tolerance of weight much from this stated value. Dimensions of this motor are mentioned 150, 100 into 200. Continuous operation of up to 8 hours in one go is expected. And input voltage here is little different. It is 36 volt 500 hertz. So this motor, this is like basic element of gyro stabilizer of tank T72. And this is one of the standard item in Russia, and we got a TOT of tank T72 from Russia, and this particular motor has been imported till now. So we are expecting this motor to be developed here, and once this motor is developed, this is one of the core technology. So once this motor is developed, a gyro stabilizer based on this motor can be developed indigenously as well. So this is all about the 4 challenges which India Optel Limited has projected in this 6. Thank you for your patient listening, and I hope we could explain, or we could at least brief you about our 4 challenges. And now if there are some questions, we can discuss them.
Hello, sir. Good afternoon. This is Balaji from Torcon Power Drives, Coimbatore. Sir, what is the dimension is very critical in this one? What is the dimension for this stator, sir?
Which one you are saying? Torque generator?
Torque generator stator 800 and 1000.
Okay. 800 and 1000, just 1 minute. Very good.
And the other point is like the requirement is only for the stator or the complete assembly?
Sorry? Can you repeat the question, please?
Sir, the requirement is only for the development of the stator or the complete assembly, including the rotor?
The challenge is basically for the torque generator only.
No, this is challenge is for stator only. Rotor we have got one assembly which is mechanical in nature.
Okay.
And dimensions you asked.
And is the dimension very critical?
Dimension is very critical from the point of view of fitment, because if you change the dimension, then it will not be form fit.
Okay,
So
okay.
you need to have the exact dimension so that it can be fitted in
Okay.
the existing structure, because it has to integrate it with other assemblies.
Okay, sir. Okay.
Dimensions, you leave your details, we will share with you. I think I have got document, I need to find it out.
You can drop us an email.
Sir, good afternoon, sir. I'm Commander Chais from Art Park, Bangalore. Two questions. What is the timeline we are looking for each of the challenge? And is it to be taken on by one entity, or you're looking at multiple entities taking on different challenges, which are 4 of these?
I think multiple entities can also take the challenge if they are willing to. And timelines, we expect this to be developed in a time frame of about 6 months. So we have 6 months to 9 months is, I think, a reasonable time for development of these assemblies.
Yeah, 6 months, maybe too less.
Is it? These timelines we can discuss once you have got your concept, like we have a solution, and
Sure, sir.
depends actually whether you are going for your own solution.
Are the documentation, the original Russian documentations available of these components?
We have Russian documents with some limitations, because these items, some of the items, not this particular item torque generator, but some like torque that stabilizer motor, what we talk 3-phase motor. That motor is bought out item in Russia. It is available in market. I mean market, but only for defense. So those items which are bought out item in Russia, for those items TOT documents are not available. We have got only broad specification and testing documents. But this torque generator 800 and 1000, we have got documents for manufacturing as per Russian design also. But we want startups actually to have their own solutions, because if you go for Russian design, then the dependency, like if it has got components which you need to import from Russia, then the purpose will not be solved. Our main purpose here is to indigenize this item and reduce the dependency on Russian imported parts.
Okay, so we are looking at own design while preserving the form factor, right?
Yes, own design, preserving the form factor, it should be form fit. Input output should remain same, but it should fit in the same existing setup.
Okay, thank you, sir.
So, and what are the numbers you are looking at for the stator, sir?
For the stator, we are looking a number of around 80 to 100 per year.
Okay, sir.
And the numbers are similar, sir. Commander Kaisari from Art Park. For the
similar
gyroscope?
Yeah, for 800,000 plus gyroscope, all these T90 assemblies first 3, it is same. And for T72, it may be between 50 to 80, but approximate. T72, last challenge which we shown that motor of T72, that may be around 50 to 80. But T90, these 3 challenges, we are looking for quantity around 80 to 100 per year.
And is there any minimum order quantity that is going to get ordered upon development of successful prototype?
On first development, I hope 50. 40. Okay, 40 numbers, sorry. To correct myself, around 40 numbers will be the assured order.
For T90?
For T90, yeah. Now, even T72 also, everything, all these 4 challenges, 40 numbers is the first order. After that, we have annual requirements.
Okay, and if multiple innovators are able to innovate, then how is it going to work out?
Then the quantity will be distributed in 60-40%. 60%.
Quantity then can be distributed in 60-40 ratio, or depending on, I mean, if the rates are met, the procurement procedure.
Okay, thank you.
Do we have any more queries for this challenge? For IOL challenges in
Yeah, you send it around.
Hello. Yeah, Mr. Balaji. Are you there, sir?
Mr. Balaji, are you online? Because you asked one query on dimension.
Yes, sir. Yes, sir. I'm there.
Okay. So the dimension of torque generator 800, this is around 25.5 mm in dia.
Okay, sir.
And for 1000, no, sorry, it was for 1000. This is the smaller one. And for bigger one, it is around 89. The exact dimension, just you drop in the email to my email address. We will share the exact dimensions. But this
Okay,
is
sir.
order of like this, like 1000 is 25 and 800 is bigger, that is around 89 mm.
Okay, sir. Okay. Thank you, sir.
if all queries are addressed, then we can move to. Thank you, Thakur sir, for your presentation and all the queries. I hope that all are addressed. And if any further queries will come, we will surely get back to you by mail or something like, or we can directly connect the startup with the respective.
Sure. They can drop in the email and we will be happy to reply them.
Definitely, sir. Definitely, sir. We'll do that. Now we would like to invite GSL to present their challenge. Samir sir, are you there?
Yeah, good afternoon, sir. Am I audible?
Hi, yes, sir, you are audible.
Okay. Okay. I'm just sharing my screen. You can see the screen that I'm sharing.
Yes, sir, we can see.
Okay. Our challenge in this 7 is basically on AI-based condition monitoring system for yard assets, and the system that we are looking for to implement this is for our ship lift and transfer system. So before I get into the details, I would just like to show one video that is there. The screen is still visible, sir?
Yes, we can see it.
So this is how basically the ship lift and transfer system here works. This is the visual representation. There is a platform that goes in, then the ship is basically guided into the.
We are seeing your title slide, not whatever you're showing.
Oh,
No
okay.
visual
I'm so sorry.
representation.
I'm so sorry. 1 minute. One minute. कैसे निकलता है? कैसे निकलता है? 1 minute. Oh, sharing का निकल.
Sir, I think you can reshare your screen because we are able to see only the first one.
Okay, 1 minute. No, 1. Okay. Okay, it is there now.
Yes, sir, it is visible.
एक पूरा picture में Okay, so this is a visual representation of how the ship lift works. This is the platform that is goes down, and the ship is basically guided into the area where it has to be, where it is brought on top. The winch system and pulley system is used with steel ropes, basically that guide the ship into this area. And then there is winch system and steel ropes that are installed on the left hand side and right hand side of the. You can see those blue small boxes there. So this is what is used to bring the platform on top. So our issue exists here. You can see these are basically steel ropes. So this is what our issue is basically. Now when okay, when these steel ropes, okay, let this video get completed. So this is the hydraulic support that is there. And then the platform is raised. Now this is the winch that we want to highlight here. Share the PPT once more. So the ship lift and transfer system, basically the overall length of the ship lift is 120 meters and the breadth is 25 meters. Lifting capacity is around 6,000 tons. And then you can see this is what we had displayed earlier. These are basically photographs that have been pasted here to have a greater understanding. And then it, the pulleys and the wind system that are there installed at the side, they use steel wire ropes. Okay, and then there are 14, winches on the left hand side and on the right hand side of the platform. And then these wire ropes, which are there on the winches, consist of an independent core and strands around it. Now, what our issue is that GSL's issue is that uh, these wire ropes are susceptible to degradation due to mechanical as well as environmental loads during its service life. The thing is that it has to be greased. It has the steel wire ropes have to be in greased condition, and when they are in water, there is sedimentation that is taking place. So mud gets stuck on this, and then they become dry, sort of thing. And then due to wear and tear, there is tendency of the steel ropes getting weak. So yeah, so the sea floor under the ship lift accumulates mud and sand and affects the area under the winch installation, leading to corrosion and other effects on the steel ropes. So this is what our basically issue is. Now we want to have a condition monitoring system, which monitors the health of these steel ropes, and then basically has a check on the sedimentation that is there under the platform of the ship lift, so that there's we can do something about it. Maybe dredging can be undertaken, to get rid of the sedimentation, and then have a health monitoring such that uh, this the steel rope's health is monitored so that it doesn't become weak, and periodical maintenance can be carried out. Now what the process is being undertaken is that there is a NDT test that is carried out on ad hoc basis whenever we feel that we need to check the health of the steel ropes. Subcontractor is hired, the tests are carried out, and then the report is checked, and then if any action needs to be taken, it is taken then after the tests are carried out. But these are not on periodical basis. Whenever we do a visual inspection, we feel that something is wrong or the steel rope is not healthy, then we do this kind of inspection. But then the issue is that these are continuously wound, and a small weakness in the steel rope leads to the single weak link, may cause hazardous, may cause have effect on the whole system, working system. So this is what the issue that I wanted to highlight about, and this is what our problem statement is. Basically, we want a AI-based system which will monitor the health of these steel ropes, and basically have a check on the sedimentation or the that is being accumulated under the ship lift platform. This is what the challenge statement is all about. Was I clear, sir? Any questions?
Sir, you all in the challenge you also talked about the cranes. Is that not a part of the scope? Do you want to just focus on the ship lift
No.
system to begin with?
Yes, at the moment, LLC crane is not a part at the moment. But then, if it all goes well with this condition monitoring system of the ship lift, then we would like to take it ahead. That is what
Okay.
the as of now.
Okay. So, and for the ship lift system, for the video you showed, it has got a control room, and it has got some automatically controllable
Yes, yes,
system.
yes.
So, do you want the sensors and the data to be integrated with any existing systems, or can this be a standalone?
It can be a standalone, not necessary that it has to be integrated with the system that is already software that is already there.
Okay. And the data which is coming from the sensors and so on, can those sensors be connected to any cloud platforms, or should that be on-prem?
It is recommended that we have it on premise. Cloud based
Okay.
is not recommended for security reasons.
Okay, sir. Okay, understood. And what is the timeline you would expect from this?
10 to 12 months.
Okay. Okay. And do you, and in the challenge statement, you called out multiple types of sensors, vibration, temperature, and acoustic, and so on.
Yes, but
Are any of the sensors currently being used, or do you have a preference of which sensors, or do you expect us to propose sensors and placement and so on?
I expect you only to propose the sensor, bring out the complete solution for us.
Okay. 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 And yeah, understood, sir.
Okay, thank you.
Thank you. And if there are any further questions, can we contact you somehow?
Sure, sure. I'll given my contact details, email ID, and mobile number. If anything is there, you all can get back to me so that I can help you all.
Yeah. And last question, sir. One more thing I thought of. The ship lift and transfer system is, can we modify any of the winches and so on to place the sensors, or how much scope is there? Is that an externally bought product which cannot be touched, or is that internal designs and we can?
Modification of the winches is not recommended as of now. But then, based on the solution, if it is feasible, study can be done.
Okay.
On how to implement it. But then, straight away, we cannot, just dismantle it, and because it
No,
is
no, I'm not expecting dismantling or something, but okay, understood. Yeah. And you said you use an NDT technique from an vendor. Can
yeah.
you describe a little bit more details on that, sir, just for context and some background? What technology is it? And
I'm not aware, sir. Actually, I'm sorry. The person who is in the concerned section is not there with me. But then
I
I
see.
can get
It's
back
okay.
to you on this as soon as
Yeah,
possible.
definitely. Yeah, I can leave my I can leave my contact details in the chat as well if you can.
Sure, sure.
Thank you. Thank you.
Yeah, thank you.
Is there any more queries for the GSL challenge?
Yeah. Hi, this is Suryakant. I'm calling from Greentex. We are an MSME company based out of Gurgaon. And I have some questions for Mr. Samir. Yeah, hi. So as I understand, because Mr. Dr. Pavan also asked some questions, so we understand the asset that to be covered under this challenge is only the ship and lift and transfer system. Because in the scope, in the details, it was mentioned about LLC cranes, or LLCs also 60 ton and 45 ton. So that is not scope within the scope. Please correct.
Yes, that is not there right now. Based on the solution that we get and how it gets implemented, we plan to take it forward on the other assets also.
Okay, and within the ship, this lift and transfer system, you're only looking for the cable management, the SWR.
Yes.
Steel wire ropes, which are getting deteriorated, and you need a periodic maintenance, or a message to your system.
Correct. Exactly. That is one part, and the second part, what we are looking at is, there is constant sedimentation that is taking place. So below the ship lift platform, due to which also the sediments that is deposited affects the health of the steel ropes, because grease.
Saline. Yeah, it's a saline water.
It's saline, and then the grease gets dried out, which is also a factor in due to which the health of the steel rope gets affected.
Right.
Due to the saline water and due to the sedimentation that is there below.
Okay. So is there any periodic greasing that is carried out right now in these ropes of all the 14 systems?
Periodic greasing.
Yeah.
Yes, that is being done. But exact period I am not aware of. I'll get back to you on this.
Okay, so what we would like to understand is the frequency of this, and the other thing is, I understand you also carry out the NDT testing, but the periodic is not, it is more on visual inspections.
Yes.
As and when on need basis, but no frequency of this periodic maintenance is not there.
Yes, correct.
Okay. And since these ropes are controlled by these motors, which are part of this system, so these motors also are somehow connected. I'm sure they're connected, but do we have a common? Because I saw one of the picture while you were showing the video, the controller sitting on top of the cabin is viewing that. So the records of, because in your problem statement you had mentioned the vibration and other parameters to be monitored. So are these already being monitored by this central, desk?
No. These are no. None of these are being monitored.
Okay. And there are no current sensors right now, as I understand. You explained to Mr. Dr. Kaman, right?
Yes, there are no sensors as of now.
Okay, and the mostly you said the defects are basically the loose strings, or sometime a cable within that wire is broken and that becomes the weakest link. So has there, do you replace it completely, or you just, how do you solve the issue? Only by greasing?
This we have not replaced as such the full cable. I don't know. I'm not aware of the details, but I'll get back to you on this. What measures have been taken if there's a because I'm not the correct person who is working on the system or is in the concern section. Actually, he was supposed to be there with me today, but then due to some reasons he's not there. I'll get back to you on this.
No problem. So just on an overall side, because this is an entire system, and SWR or the rope is only one component of this. So for us to consider, is it only the rope that we have to monitor based on AI, the health of the ropes?
At the moment, yes.
Okay, only the health of the ropes.
Yes, health of the rope, and yes, basically that is it. But then if you monitor, my question here is, if you monitor only the health of the ropes, now say, I don't know what sensors are being what sensors will be installed. But then how will you come to know if there is grease on the rope, or it is gone completely dry, or there is, due to the mud that is accumulated below the surface, uh, there is rusting that is being taken place, all that stuff.
Yeah, that is what we wanted to understand as a part of this discussion, and then we'll have another round of discussion internally with the subject matter expertise of the SWR, and that is the purpose of this outreach. So now that we understand that is a rope is to be covered, I'm sure we'll be able to come out with a necessary mechanism or a sensor-based thing which can help us to monitor this.
Great.
So that is not clear. So now that we understand, we'll work on this.
Sure.
And so usually the system is used 24/7, or is it just once in 3 months, once in 1 month? What is the way?
It is usually once or twice in a week.
Okay, so the entire mechanism, lift and transfer.
It is basically like, we have ships for repairs that are here, and then ships come for guarantee refit. It depends. Now, when there are a lot of repair vessels, the frequency is high, and then when repair vessels are not there, the frequency is low. On an average, you can consider once or twice or thrice in a month, or maybe more or maybe less, depending. It is not that it goes like this only.
But it is not running 24/7. That's clear, right?
No. It is not running 24/7.
Okay, understood. All right, I'll just ask my another colleague, Siddharth. Do you have any other question apart from this?
No, sorry. I think that this was made very clear. Thank you so much, sir. And we'll get back to you, of course, with more technical questions if we do have.
Sure.
Yeah, please allow us, because to understand the scope is the main concern. And thank you very much for bringing out this so nicely and showing us the video. So thank you so much.
Yeah, most welcome, sir.
All right. Thank you.
Yeah, thank you.
I have one more follow-up question. This is Pavan Anirudh.
Yeah.
So you mentioned that the system will be used 2 or 3 times a week or so. If the rope is bad, when would you like to know? Would you like to know before you start a new ship lift operation that everything is good? Or during the operation, if you detect that some rope is bad, can you take preventive actions immediately?
No. We would like to know much before,
Okay,
when
as it is degrading.
yeah, when it is deteriorating.
Okay, so you'd like to know the trend, how it is. Yeah, all right.
Yes,
Yeah, okay.
exactly, yes.
Okay, understood. And you said that you do the NDT when you do visual inspection and see something is bad. What do you look for? Just cables wearing a thinning at some places and so on. Is that what you look for?
We look for places where actually the steel wire ropes are greased. Where we look for patches where there is no grease, or we look the area where there is rusting, and then whether there is strands have been cut, or those sort of things.
I see. Okay. Thank you.
Yeah.
Queries are addressed for this particular challenge. So thank you, Sami sir, for clarifications of all the queries. So now I would like to have GRSE to start with the presentation, please.
Yeah, good evening, sir. This is Anandra Bhattacharya from GRSE. Am I audible, sir?
Yes, sir, you are audible. You can please start.
Yeah. Yes, please allow me to share my screen. Is it visible to you, sir?
No, sir, the screen is not visible.
Hello. Is it visible, sir, the screen?
No, sir, no screen is visible to us.
Yes.
उसको हटाओ, उसको हटाओ, उसको हटा के इसको लगा लो और तुम फोटो भेजो, है ना? एक फोटो भेज लो, मैं इसको उसको भेज देता हूँ। तो तुम्हारी फ्रेंड है ना जो, है ना, उसी को भेजना है ना।
Sir, are you presenting or is there any technical glitch by your side that you're not able to present? Sir, if you need some time, then we can go to YIL first, and after that you can present. We can go for the GRSE. Anandrup sir, are you there?
I am there. Commander Bhaskar sir is sharing screen actually.
Okay, sir, please.
On behalf of GRSE.
Sir, I think we can move to YIL first, and at last we can go for the GRSE. Till then, they can sort it out. Means, so YIL means.
Yes, can we share? Shall we share the presentation? Shall we share the presentation?
A representative of YIL can start this
Shall
session,
we
please.
share? Am I audible?
Yes, sir, you are audible. You can please share your screen.
This is Simran Ji from Manufacturing Ambajani Unit of YIL. Is this presentation hello? We have shared a presentation. Is it visible to all? Hello, sir, is it visible to all the presentation?
Yes, sir, it is visible to all. You can please start with it.
So, challenge given by us is this of copper oxygen-free copper rods. Actually, this rod is being used in the liners of our ammunition, which we are supplying to manufacturing Bhaiya. We got this drawings and all this ammunition drawings from the effectively Sweden via TOT transfer. And this oxygen free, if I directly come to the application part first, if I directly come to the application part first, you can see that this copper liners are being used in all the shape charges to develop in the heat ammunition, that is high explosive ammunition. At a particular time it forms, it converts into the semi-molten form, which directly penetrates into the armor plate of the tank and finally destroys it. So any anti-tank ammunition is fitted with the shape charge, and this shape charge requires the uh, 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 material to be the copper, and any other material according to the purity of the material, we can use it in different forms. But here we are given copper only, which is oxygen-free copper. So these are the um, standards which are guiding the specifications of these rods of the copper. ASTM D170 grade 1 and TN13604. Basic properties of these coppers are, first of all, it should be the 99.99% pure copper, and in the second one, in EN13604, we require that oxygen content must satisfy the corrosion and brittlement test. So right now the problem is that we are not able to source this material indigenously. We have to depend a lot on our local vendors, which try to import it from the other nations, and which lead to heavy delay in our production facilities. We are having a huge business potential in this, but still, because of non-availability of material, we are lagging behind a lot, supplying this ammunition to our concerned sister factories in Jabalpur. So we are in desperately in need of this if anyone can help us with it. Thank you. Any questions? question, or shall we move to the next thing? Hello. Hello.
Yes, sir, you are audible. Please go ahead.
So this was the first thing which we shared about. And shall we move to the second one, or any questions from this thing?
If anyone is having any query, they can ask for this particular challenge, or we can go for the next challenge also.
Now we are moving to the second one.
Yes, sir, you can go for the second one, please.
My colleague, Ms. Niti, she will share the details of the next challenge.
Hello. Hello, this is Shruti Yadav from Morgan's Factory, Ambajeri, one of the YIL unit. I'm here to discuss one of the challenge that is regarding rubber fabrication of three main components. 120 mm steel cup, army plus filter, and one of the application I show for steel cup is that it is used in T72 tank, and it is used as a cartridge case only, and it should be easily extracted. And the upper part there is you can see the rubber vulcanization. So these are the specification of the rubber that is as per the specification it should be DPT 818 class F3 with the rubber hardness of 60 plus minus 5 ppm. The material should be chlorosulfonated polyethylene rubber with the specification as shown. For the components, our business potential is huge, that is 1.10 and our monthly requirement is 5,000 to 10,000 numbers. These are the properties we require after the vulcanization, that is the tensile strength, elongation and break, hardness, and change in tensile strength, and the resistance. Right now, we are purely dependent on Elma, but it's the rate of production they are supplying to us is very less, and that is why we are not able to accomplish our target. So we are in need so that we can have more better suppliers and we can fulfill our target timely. This is from my side. Any queries or anyone?
Any queries for the YIL challenges? For both the challenges, if anyone is having, please ask.
Okay, I think nothing right now.
I hope that we don't have any query for these two challenges currently. If any query comes up in our portal on our website now, we will surely get those query to you. And if anyone feels to ask any question afterwards, now we will share the contact details of YIL over that particular page where we are flashing the outreach event schedule. So now we are going to have the GRSE again, and on behalf of GRSE, I am sharing that that presentation, and we can go for that discussion. So I request YL to please unshare your screen, please. Sir, you can go ahead, sir, please. I had shared that screen. I hope that it is
Yeah.
visible to you as well.
Right, right. Thank you, sir. And good evening to all of you. Our challenge statement for DIC6 GRSE is development of AI-enabled welder's helmet, amalgamating the concept of ear headset and conventional welder's helmet. So we can move to the other slides. Right. Let's talk about the present challenges the welders are actually facing. So this is this, as you all aware that welding is carried out by a welder at about 4 foot distance from a blinding bright arc and a melting steel of temperature about 1200 to 14 degrees centigrade. Conventional welding helmets allows the welder to see only the arc and not the job, so compelling the welders to use muscle memories. And at present, in India, no technology is available for the welder to view the real-time welding parameters compared with the ideal range of WPS, that is welding procedures specifications, thus inhibiting immediate corrective action during the welding. So the next slides. Yeah, this is kind of the present scenario, and we also have that in our shipbuilding industry is a huge, enormous amount of welding work is going on day-to-day basis. So this is the actual scenario in left side, and the right this is kind of schematic presentation. We are trying to amalgamating this VR technology or AR technology with this welding helmet, sir. So next slide, sir. Yeah, in the succeeding slides, what we are going to discuss about the operational or functionalities and capabilities expected or we intend to develop through this AI-enabled welding helmets. Let's start with this development of AI-enabled welding helmet mounted with 2A camera with suitable sensors, allowing the welder to see both the job as well as the bright welding arc at the same time, which is for present it is very difficult for a welder to see both the jobs at a single time. And this we intend that AI-based system in the helmet should be able to compare the real-time recorded welding parameters with the ideal range of welding parameters as per WPS mentioned earlier also. So next slide. So you can move to next slides. Right. Thank you, sir. The helmet should have wide display area for real-time controllable welding parameters like these are some basic parameters like traverse speed, electrode stick out, distance from the electrode to job, voltage, current captured from welding machines, and this may require interface between welding machine and the helmets. So next slide. Yeah, thanks. And this helmet should, the display system specifically should be have the ability to provide feedback to the welders on the helmet screen in a color-coded manner. For example, green for parameters in range, the red for parameters out of range, the parameters what we have discussed in the earlier slide, and on comparison of the real-time welding parameters to the ideal WPS range, enabling the welder to take immediate corrective action. And there should be a provision for the welder to upload and select the relevant WPS prior start of welding job, which is very specific for a particular job. And option to take the feed from the suitable welding machine is also acceptable and desirable. So next slide. And the solution, this helmet should be a rugged, lightweight, and comfortable product for the welder to use for a relatively prolonged duration. It could be 5 to 6 hours based on the job that day particularly. and there are some standards are there, NSA standards or CSA compliance standards are there, so that it should be well built as per these standards, considering the safety aspect of the welding helmet also, sir. And it may could be housed with rechargeable and replaceable battery with appropriate capacity, allowing unhindered usage of the prolonged periods. Next. Yeah, the last one says the storage space enough to store WPS data as well as real-time welding parameters recording from continuous usage of helmet for at least 1 week or 6 hours per day usage. So these are the requirements, functional requirements we are expecting while developing this AI-enabled helmet, sir. There is, I think, left with one slide, sir. You can proceed to the last slide, sir. Right. So the startups or MSMEs, they can, sir, collaborate with reputed academia like IIT Kharagpur, IIT Chennai also. Building societies are there, IWS or research facilities like WRH, Vichy, having requisite expertise and facilitating welding domain for co-development of the prototype and testing of this equipment in their facility. So this is all from us, sir. Thank you, sir.
We can have questions for this as well. Any query for this particular challenge? I think that we don't have any queries for this particular challenge as well. One query was there in the online. I hope that we might have this one. So I will ask on behalf of that one. Just a minute.
One question, Vishal, for this. After your question, I can ask.
You can ask your question first, and I'll try to figure out that one.
Okay, what is the time frame that you're expecting for this solution to be given to you, sir? Mr. Anandrup, sir, this is Suryakant. Sorry, I'm not able to hear you, Anand, sir.
Sir, it could be 10 to 12 months.
Okay. All right.
Basically, basically helmets are available. Is basically the image processing part, the VR part, the amalgamation of VR part. So I think 10 to 12 months will be the expected timeline.
Okay. Because what we foresee that it will not only need VR, it will need AR solutioning, not
Right.
the VR. All right, we'll come back to you now that we understand the scope better. And if our team is able to, come out, we'll come back to you. I think we'll get the coordinates from Vishalji, and then we'll contact you. Thank you.
Sure.
Surely you will get the details. By tomorrow, you will get the details from the website.
Sure, no doubt. Dio is really, really efficient. I must say that. Thank you.
So we have one question from Sri Shakti. I hope that he might not be able to join this session, so I will ask on behalf of him. The question is, can we develop AI-enabled retrofit model to be used in existing helmets, or should we design the AI-enabled helmet right from scratch? In both the cases, kindly give us the helmet specifications to design accordingly.
I don't think it's a retrofit kind of thing that has to be developed from the scratch, I believe, sir. So because this AR and or VR concepts and this specifically this camera image processing part that has to be combined with these helmets. So I think it's not kind of a retrofit thing, sir.
Okay, thank you very much, sir, for clarification all the queries. I hope that is there anyone having any more queries for this particular challenge, or we can go to shut means we can have this session end it.
Yeah, Vishal sir, this is Dinesh Natarajan from Welkenrum Technologies. So sorry that we had some issues. We couldn't able to join initially. So we have some queries with other challenge. If at all possible, shall we discuss it right now, or should I reach out in some other time?
You can ask if the nodal officer is present. He might be able to answer your
Okay,
question.
it's about this IOL challenge, development of gyro motor and torque generator. Very basic questions I have. So whether if at all the torque generator and the gyro motor can be of different motor specifications. Suppose the present ones are induction motors or some other type of motors. Can we change the specifications of the motor, or can we use a different technology motor without compromising the application or the specification performance?
Mr. Dinesh, we request you to please repeat the question, please.
Yes, sorry. Yeah. So I have a question. My question is: suppose the gyro motor which is being used presently is of a technology, say per se induction motor technology, and if at all we want to change the technology to some other motor like SR motor or synchronous reluctance or BLDC motor, PMSM motor, can we do that? So with we will not compromise anything on the performance, we will not compromise anything on the specifications or the functionality. Can we achieve the same performance in different types of motors?
Yeah, so understood your question. So I think, yeah, that is possible. That's why I made this point during my presentation also, I think, or answering one of the query. Like you can change the technology, only our
Okay.
end specification should remain same. Like whatever is the input to the motor and whatever is the output, output is torque only. So that should
Okay,
remain
right.
same, and it should be form fit. So your new
Understood.
solution, we should be able to fit in the existing one without changing any dimensions. So
Right, sir.
dimension should remain the same, weight should remain the same.
Okay, okay. So, sir,
Dimension
regarding
is very important.
right, sir. So, regarding these dimensions, will we be given the details of the dimensions when we will be given that, and how we can achieve that? That means get that from you to do the designs.
Yeah, yeah.
So,
You
what?
can drop me an email to exact dimensions as per drawing. We will share with you.
Okay, okay, sir. So the email ID is like I'm corresponding to one email ID where from which they have shared this invite links. So same email ID will correspond.
Is it the same? No, or you can note down it is CS Thakur. CSTHAKUR CS Thakur.
Okay.
@ord.gov.in. I just typed it also on the text.
The chat box, you can see the email.
Yeah, right, sir. I saw it. CS Thakur. Okay, sir. Yeah, I got it. So one other question from my side. This will be the final question. So is it? I just want to need the electric specification, like what will be the power supply and what will be the frequency of it, so that we can plan accordingly on that.
Okay. So at the moment we are planning 40 numbers. If it is developed successfully, the 40 numbers will be the first order quantity, and subsequent years torque motor and gyro chassis, that is 50 to 80, around 80 per year.
Okay. Okay.
And you are interested only in torque motors, no?
Both, sir. We are working on both. So will that be possible? Like we can give a proposal for both, because the technology is very close and maybe 20% deviations from here and there technology,
Yes.
but
Yes.
we can compete for both.
Okay, so yeah, it is around 80 maximum 100, like around 8 average you can say 80 per year
Okay,
for
sir.
subsequent requirement.
Okay, sir. Sir, what will be the power supply input to that voltage range?
Input supply to this torque motor is 36 volt, 400 hertz. That is excitation voltage, and there is a control voltage also. That is
Okay.
also three phase AC. That is 0 to 30 volt. It can be in the range of 0 to 30 volt.
Okay.
And 400 hertz.
Okay, same 400. So it applies for both the torque generator and the gyro.
Yeah, both the torque generator and gyro.
Okay.
In gyro chassis, there is no control voltage. There is only this input voltage, excitation voltage. But in torque generator, there is excitation voltage which will switch it on, and then there is control voltage which will modulate the torque output.
Okay. Okay.
Yeah.
Understood, sir. Yeah. So these are my questions.
Yeah. Okay.
Thank you, sir. Thank you very much.
thank you very much. And do we have any more queries? I hope that let's end this session because almost all the queries has been already been addressed, and I would like to thank all the DPSUs and their nodal officers who joined and presented their challenge in a very nice and had all or addressed all the queries that has been asked by the startups. So this session will be this recording will be on our YouTube channel. We will try to upload it by tomorrow, and this link will be available to all. So thank you everyone for joining this session, and now we can end this session. Thank you.
Thank you.
Thank you. Thank you, everyone.